Hello friends, today I am going to show you how inter-VLAN routing works. For this, first I have taken a router and I have taken two switches. Then two PCs are connecting to my first switch, another two PC to the second switch. And for the console purpose, 3 PC I have placed. Now I am connecting the media fast Ethernet to the switch, fast Ethernet to the switch. Similarly, this is the first Ethernet to the switch 1 and the first Ethernet to the switch. Now I have to connect these two switches. For this I have taken a crossover first Ethernet. After this I have to connect my switch to the router. For this I have taken first Ethernet router. And for the console purpose, to PC RS232, this RS232 to the switch console port to the PC RS232. So I am going to make this 4 PC belongs to 4 different subnetwork, each having particular VLAN. Say for example, for the first PC, let's say it belongs to the subnetwork 192. Its network ID, let's say 92.168.1.0/26. This broadcast IP is 192.168.1.63. Let's say its IP address 192.168.1. Let's keep it blank, the IP address, the gateway 92.168.1.1, and the subnet marks 255.255.255.192. So it means the first 3 bytes are assigned for the network address, and the last byte is for the host address. So 192, we have 192, and the total it can accumulate is 250, 255, or you can say 256. Total 256 it can accommodate. So 256 minus 192, it will give you 64. So 64 addresses this subnetwork can accommodate. So from 1.0 to 1.63, it is total 64 addresses, and out of these 64 addresses, 3 address, which is 1.0, 1.1 gateway, and 1.63 are reserved. 1.0 is reserved for the network ID, 1.1 is reserved for the gateway IP, and the 1.63 is reserved for the broadcast. So out of 64, 3 are reserved. So IP addresses which are available to assign to the PC are 64 minus 3, which gives us 61 addresses. So we can assign from starting from 1.2 up to 1.62. So let's take here our IP addresses as 1.10, for example. See, so I'm assigning the IP addresses here. My gateway 192.168.1.1, my IP address 192.168.1.10, 192. See, and for this PC1, this again belongs to another network 192.168.1.64/26, and the broadcast address, broadcast IP 192.168.1.127, and IP address is 192.168.1. Execute blank gateway 192.168.1.65, subnet marks 255.255.255.192. Here also subnet marks is 192.255.255.255.192, which means 64 addresses. So from 1.64 to 1.127, total 64. So out of this, 3 IP addresses are reserved. So available IP address to assign to the PC is from 1.66 up to 1.126. So let's say I've taken here IP addresses as 70. Yeah. Then gateway is 192.168.1.65, IP address 192.168.1.70, the 192. So for this PC2, let's say its network ID 192.168.1.128/26. broadcast IP is from 92.168.1.191. 192.168.1. Keep it blank for some time. Gateway 92.168.1.29 and split marks 255.255.255.192. So here again, so one from 1.128 up to 191, total 64 IP addresses. So host IP address or IP addresses which can be assigned to the PC are from 130 up to 190. So let's say 140. 192.168.1. My gateway is 129 and the IP address I've assigned 192.168.1.140. Subnet marks is 192. Okay, and for this PC3 192.168.1. Network ID and broadcast IP 192.168.1.255. IP address 192.168.1. Gateway 192.168.1.193. Subnet marks as 255.255.255.192. This also from 192 to 255, total 64 IP addresses. Out of which IP addresses VLANs which can be assigned to the PCs are range from 194 up to 254. So let's say it's 200. The gateway is 192.168.1.193. IP addresses 192.168.1.200 I've taken and then 192. Now I'm going to apply VLAN. Now let's say this FH01 port of the switch belong to VLAN number 10 and this FH02 belongs to VLAN number 20. Similarly, switch 1 FH01 belongs to VLAN 30 and the FA02 of switch 1 belongs to VLAN number 40. So I have to configure this VLAN. The port in which PCs are connected, it will be my access port, and ports where another switches or router are connected, it will be my trunk port. So let's go to the console first. My console. I'm bringing one more page here. Screen 2. Window capture. Yes. Okay. So okay, fine. Now let's start my configuration for this port. Enable configure terminal. I have to enable the for the interface. Wait. Let me bring the picture side by side. Okay. Interface. Before interface, I have to create the VLAN 10. Similarly, VLAN 20. VLAN 20 and VLAN 30 and VLAN 40. I'm creating 4 VLAN for each subnetwork. Okay. Now I'm applying VLAN to each subnetwork interface. First port node access. Port access VLAN 10. And similarly FA02 port mode access, switch port mode VLAN 10, set my interface FA03. This should be a trunk port, switch port mode trunk, and switch port trunk mode VLAN from 10 to 40. I'm allowing it. Similarly, FA04, switch port mode trunk is also allowing VLAN 10 to 40. Okay, we can check our configuration now. So VLAN brief. So VLAN 10 assigned to FA01, 20 is assigned to FA02, and the first trunk. FA03 is trunk port. Similarly, for this switch 1 also we have to configure. So data achievements. Okay. Okay, this is perfect. So this also enable first, then config T. Now VLAN number 30, name VLAN 30, VLAN number 40, VLAN 40, exit. Interface FA0/1, port mode access, port access VLAN 30, FA0/2, port mode access VLAN 40, FA03 port mode trunk, and switch port trunk load VLAN from 10 to 40. And let's see the configuration. So VLAN brief. So VLAN 30 is assigned to FA01, VLAN 40 is assigned to FA02, right? And so to first trunk, FA03 is the trunk port. So I have assigned IP addresses to its subnetwork and assign VLAN to the corresponding port of the switches. And now we can first, let's see whether can PC0 can communicate with PC1 similarly with PC2 or PC3. Okay, so bringing the PC0 is which one? Wait. PC0 have to create one more. Okay, fine. So let's ping the. So what I'm going to do here is I will ping the IP address of PC1, then PC2, then PC3 from PC0. So PC1 IP is 170. One 170. Yes, it is seen here. It is not pinging. Similarly, we can check for PC2 which is connected to a different switch, and it's now we can check for PC2 also. Its IP address is 1.140. So which is not pinging. Similarly for PC3 which is 1.200. This is also not pinging. Now I will configure for this router, and before that, before I configure this link, connecting between switch and the router. Physically it has only one single link, but as we have 4 different sub network having separate VLAN, I need 4 link, but physically I have only one link, so I will logically divide this single link into 4 logical interfaces. So let's move ahead for it. Let's title TR. Okay. Enable bring it in config mode, then interface FA0-0, the first logical interface, which is for the VLAN 10 having the IP address, the gateway IP address of VLAN of the VLAN 10. 2.168.1.1.255.255, which is this IP address is the gateway IP address of our first subnetwork. This gateway IP address will be the IP address for the first sublogical interface. Okay. Then similarly another second logical interface. This will for the VLAN number 20 having IP address to our next subnetwork has the gateway IP address of 1.65. This gateway IP address will be the IP address for the second logical interface. Okay. Then third logical interface. This will be for the VLAN number 30 having IP address as the 129. My fourth interface is this 40 and having IP address as 193. And I'm bringing my physical interface FA0/0 status to up, so no shutdown. So here, as I activate this physical link, my switch interface is also booting now. So as soon as this color become green, the link will be active. We can check our configuration also. First, brief. Here we have assigned, this is our physical interface fi0/0, which is logically divided into 4 subinterfaces: dot 10, 20, 30, 40. It's having the IP address, which is the gateway IP address for the corresponding subnetwork. Okay. Now let's ping again from PC0 to PC1, PC2, and PC3. So ping for the let's ping this PC1, which IP address is 1.70. And it is pinging. Similarly, for the PC2 having the IP address 1.140. This is also pinging. And the fourth PC having IP address 1 to 200. This is also pinging. Correct. And the same thing we can also see by simulation method also. this PC0. Let's say I'm pinging 200. So let's see here how this is behaving. First from PC0 it goes to the switch 0. It sends the traffic to the router. The router send back to the switch 0. The switch 0 will send traffic to switch 1, which is okay, and to our destination PC. Then from destination PC again coming back to the same route. And our traffic reached successfully. Here, since our inter-VLAN communication is possible because of the of this router, and this router looks like it is sitting on the top of a stick. So this technique is also called as router on a stick. And from this router again we can connect to multiple another network through which we can connect this router to another router by serial port, which I will show you maybe in the next video. So thank you for watching.